You hear me now?
Yes, Mike, I can hear you now.
Ah, okay, very good. I can hear you too. Very good.
Thank you
How
so
are you?
much, Moi, for attending this discussion. So, how are
Of
you?
course.
How is
I'm
life?
okay. I'm okay. Long day. I've been sitting behind my desk since 7 o'clock in the morning. A lot of teleconferencing, a lot of calls, a lot of emails. So that's it. That's hard work.
I'm pronouncing your name correctly.
My name is Mo, M-O-E. The E is more or less silent.
Okay, okay, okay.
Yeah,
Thank you
yeah.
so much, Mo.
Sure. Where are you located?
Okay, okay.
I said, where are you physically located? Are you up north or are you outside of the
Yeah,
country?
I basically stay in Bangladesh. Have you heard
Okay.
the name? So
Good.
I'm
I know. I know where that is.
Bangladesh. Yes.
Actually, I have a very, very close friend of mine.
Oh,
She has a Bangladeshi uh, fiance, and she moved to Bangladesh about 7 months, more or less 7 or 8 months ago, since last year. And she absolutely loves it there. We used to work together. She's a mechanical engineer. So
okay.
very nice. She loves it there. So I've never been there.
Okay, good to know that, Mo. Mo, can you please tell me something about yourself?
Well, that's a very broad, general question.
Yes.
So, all right. But I would usually say, why don't we be more specific? But generically speaking, I am a technical individual at heart. I'm a good communicator. I have high uh, IQ. I have passed my IQ test and I know what my IQ range is. But the most important thing is the emotional intelligence. That
Okay,
means
fine.
I can connect with people, especially the people that I work with on a daily basis, on a regular basis. Uh, I can pay attention to details and I can also see the bigger picture, the top level. And I usually would like to start from the big picture and work my way down. Okay. Uh, well, right now, I have two kids who are in university. They're basically finishing their PhDs. And it's just me. I can move anywhere I want to. I can go anywhere on this planet these days. I get a job in Singapore, I go. I get a job in Sweden, I go. I get a job in Canada, I go. I get a job up north in San Francisco, I go. If it is a good job, good company, it's exciting and it's challenging, I would definitely consider it. And I appreciate technical challenge, organizational challenge, process, procedural challenges, supply chain challenges, okay, and so on and so forth. That's in a nutshell.
Oh, thank you so much, Mo, for your
You're welcome.
introduction. So, Mo, right now you are holding a very big position, leadership positions. So, this
Yes.
position is also engineering director. Is also a very big position. So, what kind of leadership skills or soft skills are required for this position?
Well, the most important thing is I have to know the roles and responsibilities of the individual who work for me. I have to know their mindset, okay, what their passion is, what their interests are, okay. Then I have to balance it against what the organization's needs are at any given time. So in reality, what it boils down to, I have to take a look at the organization and see strategically what kind of skill sets, what kind of personalities do I need in that organization. And then I find out what those holes are, what those shortcomings are. Then I will try to either manage with the resources that I have in order to fill that gap, or if I cannot do that and the skill set does not exist, then I have to go outside and bring it in. That's part of it. So development of the organization, development of the resources, intellectually, emotionally, okay, is really the key, right? Then, so that's a skill set that you need to have and you cannot forget. So once you establish that kind of a organization and you establish that kind of a rapport and communication, then you establish trust. That means now my technical staff, electrical engineers, mechanical engineers, software engineers, microbiologists, whatever they are, okay? Now you trust them, okay? You provide the general direction the general guidelines, and you allow them to move forward. And whenever they need help, and whenever I think they need help, then I jump in and I try to help, not necessarily micromanage. Okay? Try to help and guide. But these are two different issues and approaches. This is how you allow your team to evolve and to grow. Okay? And build confidence and skills. Okay? And you turn them into confident leaders, individuals. Whether they want to be technical leaders or they want to be managerial leaders. Either way, it doesn't matter. So you can always grow in a technical path or a managerial path. So that's really the crux of it. Understanding the organization, the needs of the organization, the resources assigned to you, and then aligning them with the goals and objectives of the business and making sure it supports the goals and the objectives of the business.
Okay, nice to know. Mo, I believe that you are maintaining team or you are leading team for a long time in your career.
Yes, I am.
Yes. So, have you ever faced any kind of conflicting situation among your team members?
Oh, absolutely.
Resolve it.
Yeah. There are, let's put it this way. There are personality conflicts. Okay. That is basically fundamentally could be broken down into several areas. The most important part of it is miscommunication, misunderstanding. Okay? So the moment I see that team members have that kind of a conflict, that kind of a tension, okay, I would like to ask them individually what's going on, okay, and what can I do? What needs to be done? And the most important thing is, first I would like them to air their issues. Tell me what is it that bothers them? What is it that makes them unhappy? Okay? Once I figure that out, then I want to hear the other side. What makes them unhappy? Okay? And then I want to see what the gap is, what the gulf is in between. Is it a huge gap or is it a small gap? Okay? And then I try to bring the two closer to each other by establishing, again, good communications, because the foundations of any relationship, business, technical, professional, family, sports, and so on and so forth. The foundation of it is a relationship. And the foundations of a relationship is based on good, clear, concise communication. And then you establish trust and respect. And then people know each other's boundaries and sensitivities, and then they can manage it accordingly. And then whenever something happens, you go in. So that's really what it boils down to. I have had conflict issues, and I have approached it the same way that I just described it, and it has borne fruit for me. Sometimes a little bit sooner, sometimes a little bit later, but it always works because I show them that I trust them and I respect them, and therefore I would like them to respect each other and trust each other.
It's an interesting answer.
Thank you.
More. Now I would like to ask you some generic questions. I hope you will answer it in your own way. So,
sure.
Can you name some of the companies that you've worked with that follow GMP and FDA regulations? And
okay.
did you play actually for?
So one of the things you need to know is that I come primarily from the aerospace industry.
Okay.
Okay. So in the aerospace industry, at the very beginning, going back 60 years, okay, 70 years ago, the mother of all requirements, okay, has been the military standards for military aircrafts, tanks, okay, naval weapon systems, ships, battleships, submarines, okay? So the military, the Department of Defense, established all those standards, okay? Then those standards were taken, and then FAA, okay, the Federal Aviation Administration, okay, took those and tailored it towards commercial aircraft. Then over time, the Food and Drug Administration, FDA, took the same standards, okay, and basically modified it and tailored it towards biomedical, pharmaceutical, okay, standards and applications, okay? And then automotive took it and applied it towards automotive industry. Because in reality, 65 years ago, Most of these industries didn't really have any as such. Then it's the same thing. So those standards are requirements, design, qualification, okay, production, and so on and so forth. Now, you want to go, so I have worked both on the commercial side and manned space flight. Manned space flight is extremely tight regulatory requirements, and you have to be in clean rooms. Practically everything you touch has to be in a clean room environment, okay? So contamination is a major issue, okay? Bacterial growth of whatever it is that you're producing and you're sending out into space, okay, is a major concern, okay, because you want these products to last. So they took more or less the same concepts, okay, from manned space flight, and then they tailored it towards the FDA and its regulatory bodies, okay? So because I have extensive background in the military side, on the commercial aerospace side, and space side, okay, it is very easy to cross over. My first job was actually working in a biomedical company where we produced health monitoring equipment, respiratory products, pressure, pulse, EKG, okay? So I worked in a production environment, so I saw firsthand, okay, the processes required, the procedures required, the production lines required in order to put these things together, and then test them, qualify them, and shipping them out to hospitals, and so on and so forth. So that's the extent of my experience. Hopefully that answers your question.
Okay, thank you so much. So you were saying that you maintain some clean rooms, right?
Yes. Yes.
So how many clean rooms have you designed by yourself? And
okay. So remember, I'm the user of the clean room. I'm not the designer or the fabricator or the manufacturer of the clean room. So my background is we design systems, okay? Systems that go in an aircraft and systems that go into space, okay? Those systems, quite a few of those systems, in order to survive and operate properly in outer space, they need to meet a cleanliness requirement that only a clean room environment will allow you to meet. So you have to wear gloves, you have to wear gowns, you have to wear hats, you have to wear masks, you have to wear cover for your shoes, okay, and so on and so forth. And then when you go into a clean room environment, everything has to be checked. And sometimes we didn't have to be sanitized. We just had to make sure that, our hands and our face and so on and so forth, part of it that is exposed, okay, is not going to be causing any problems. Gloves were up to here, everything was covered, and so on and so forth. So I did not design clean rooms. I just used them. I was the user of clean rooms.
Okay, thank you. So, Moy, do you have any experience in metrology? And
yes, most of our so what metrology has been historically doing is that when I order products, test equipment, instrumentation, okay, from various manufacturers for an application inside my business, those products, when they come in, they have to get certified, okay, and they have to go through a metrology department, and the metrology department powers them up, reads the requirements, okay, and finds out that this device, this instrument, okay, has to work in this range. I give it this type of input and I get this type of output. I give it this type of current, I take this type of output, right? And so on and so forth. And then it identifies it, labels it, that yes, this device for 1 year, okay, is certified to be operational. At the end of 1 year, I have to take it out of service, and usually our metrology department does that. They take it out of service, and then they send it back to the manufacturer, or if we do have a capable metrology department in-house, that metrology department in-house will be responsible of having all the necessary instrumentations in order to be able to calibrate, okay, to calibrate this. Because if we are measuring really, really down to 1 micron, okay, or less, okay, 0.1 micron, 0.2 microns, 0.10, 0.5 microns, you need the level of accuracy and resolution, okay, that these instrumentations have to deliver. And if they're off, okay, then all your measurement data, test data is going to be off, okay? And you'll be scratching your head as to why, okay, am I looking at a data which is 5% or 2% off? Sometimes your tolerances are plus or minus 5%. Sometimes your tolerances are plus or minus 1%. Sometimes your tolerances are plus or minus 0.1%. Okay, if it is 5% and my instrument is 2% off, I may be okay. I may get lucky. But if my tolerances are plus or minus 0.1% and my devices are off 2%, then all my tests, all my measurement, everything is off. Everything is wrong.
Thank you, Mo.
You're welcome.
We would like to know your experience in GMP calibration. Can you please explain?
No, I don't have any GMP background. Okay, as I said, the calibration. Okay, so practically what I can tell you is every instrument, okay, every test equipment, okay, that is used in a clean room environment or in a non-clean room environment, in a production environment, okay, it is pharmaceutical or biomedical. All of those devices have to functionally perform, pass, and they have to have the calibration necessary. And in order to, so some of them are purely mechanical systems, some of them are electromechanical systems, some of them have embedded software, okay? So that means if they're just mechanical, that's one issue, it's a simple one, usually. If it is mechanical and electronics, that becomes the next level of complexity. And if it is electronics, mechanical, and it has embedded software, then that adds another further complexity. So that means your mechanical parts have tolerances. Those tolerances are not going to go back and forth that much, okay, because it's not going to grow. Your electronics is subject to drift and aging and temperature. And then the accuracy of your data acquisition and monitoring system, which potentially has a lot of software in it, then you have to know what does the code do with the data, okay? How does it acquire it? How does it process it? How does it filter it? And every one of these steps, you have to know what the amount of error introduced into it is. So the error in the electronics, the error associated with the mechanical parts, and the error associated with the software, okay? And then you will know exactly what your GMP instrumentation or your GMP measurement and so on and so forth test equipment is able to do or not able to do, and if it meets the requirements.
Okay. We would also like to know what type of issues did you resolve with HVAC system?
With what?
HVAC system.
What is that? Okay, you have to explain that to me. I don't know what that is.
HVAC. Are you not familiar with this?
No. Would you spell it? Oh, HVAC.
HVAC.
Oh, okay. Heating, ventilation, air conditioning system.
Yes.
Okay. So, all right. Basically, I have touched upon environmental control systems and thermal control systems for space. Okay. So, I have also designed and was the engineer responsible for a chiller, okay, which is like a refrigeration system, okay, which has the same concept. So I basically had to design, take a look at, let's say, a desktop that you have on your desk, not a laptop. Let's say it's about 3.5 inches in width, about 10 inches, 12 inches in height, okay, and about 14 to 16 inches length, okay. I had to fit in 2 fans blowers with their controllers. I had to put in a 3-phase EMI filter, an AC to DC converter, several DC to DC converters, and then DC to AC inverters to drive the fans. And then I had a compressor that was right in the middle of that box, okay, that needed control mechanisms and algorithm and drivers. Then I had a hot side and a cold side, okay. So I had a condenser and an evaporator as part of the design, okay. And all of that had to fit in, okay, into that tiny little box, okay. So coming up with the proper architecture, okay, and trying to see even I could fit all of these components into that volume and real estate was really the challenge, okay. So it took us about 6 months because we had a very, very restricted volume and real estate. It took us about 6 months to finally come up with an architecture that said, yep, we can do that, okay? And we're not going to choke airflow, and we're not going to choke hardware and the compressor and so on and so forth. And it took about another year to year and a half to do the detailed design, get the prototypes in, put them together, and start working them. So basically you are looking at temperature control, flow control, okay, and monitoring the schemes and the necessary algorithm to be able to control your compressor. My fans were, I think if I remember that correctly, this is like about 10 years ago. I think they were running at about 14,000 RPM, okay, which is just like a small jet engine. The compressor maximum speed was around 4 to 5,000 RPM, okay, and depending upon where my temperature set point was, okay, how cold I wanted it to be, okay, we could go as low as 42 degrees Fahrenheit, which is pretty close to zero. You freeze, okay, and in about I think we could pump out about 300 CFM, okay, of cool air, okay, into a cabin in an aircraft, okay. Specifically, this was designed to blow cool air into the cockpit of the aircraft. So if you have an aircraft which is sitting on a hangar on hot summer days, right, and it's exposed to 3 or 4 hours or maybe more, 10 hours of hot sun in Arizona, in New Mexico, in Texas, in California, anywhere for that matter, or East Asia or West Asia, right? That cockpit, every instrument, everything, okay, that the pilots get in, they want to touch it, it's hot. It's about 140 degrees, 150 degrees Fahrenheit. So that means the moment the pilots, we know they're going to show up into the aircraft, 10 minutes before, they power up the aircraft and they allow, okay, this HVAC, okay, to blow cold air into that cockpit and cool off the cockpit, reduce the temperature so that the pilot and the co-pilot come in, okay, they don't burn themselves and they can easily handle the instrumentation.
Okay, thank you so much.
You're welcome.
So, what type of issues did you resolve with electrical and plumbing systems? Would like to know.
You name it. Electrical, power systems, control systems, communication systems, software issues. On the mechanical side, I have had load cell issues, pressure issues, okay, tolerance issues, fabrications of the parts that came in were not, they were out of spec. But primarily, I have been a very, very avid supporter of putting in proper design and design methodology and design reviews on the front end, where I have, once we start the design with proper requirements, okay, and the design starts, as it gets a little bit more mature, I like to have bi-weekly reviews, not just by my own team members. Maybe once every 2 months, I like to have somebody from the outside of the team, who has nothing to do with that project, okay, to come in and look at it with fresh eyes, okay, and see what is it that they can find. I apply the same approach to my electronics, electrical design. and I apply the same approach to my software design. Because I believe if I have proper reviews, proper exchanges of ideas, okay, especially peer reviews, I can basically eliminate practically 90 to 95% of all problems early on in the design stage, rather than wait, okay, to go into qualification or integration and then try to figure out what's going on. Most mechanical components, parts, you're basically either looking at material selection, wrong materials, okay, or you're looking at the wrong tolerances, or you're looking at the wrong surface finishes, okay. And so a tolerance to stack up analysis is the key to make sure that, and I'm talking about worst case, okay, you do a worst case tolerance to stack up analysis just to figure that one out. And on the electronics is the same thing, because most electronic components or electrical components behave differently when they age, behave differently under thermal conditions, various thermal conditions, and I want to be able to figure that out with proper analysis on the front end and then proper derating. So all my electrical components have to be derated properly so that I don't have design issues, performance issues, and so on and so forth.
Okay, thank you. I would like to ask you a question related to budgeting. So it will be a big question. So my question is, how do you prepare budget? What mechanism do you use to track the budget? What has been the largest maintenance budget that you have managed, and how did you manage this budget?
So in the aerospace industry, by and large, we use earned value management systems, which is again, which was again devised by the Department of Defense. Okay, and so let's say the last bid, my previous job, the last bid I put together for a project was $25 million. Okay, yeah. So that $25 million was electrical, mechanical, software, and then building, fabricating, testing, integrating, and then delivering the product. I basically have to estimate, okay, every piece of activity that goes into it, okay, from a requirement phase, okay, to initial design, to the reviews, and I anticipate who's going to participate, who are the skill sets that are going to review, how many times I want the review to exist, and then I go into preliminary design review, okay, and then I come out of that, continue with my design, and then I do my prototypes and stuff like that, and then eventually I end up going to my critical design review, and I have to estimate that. I come out of the critical design review, now I say, okay, I'm ready to go into qualification. I estimate qualification testing 3 months, 6 months, 9 months, a year, depending upon the product and the industry, okay? So I know for my mechanical qualification, what are the tests? I know for my electrical qualification, what are the tests? I know for my software, what are the tests, okay? And I estimate all of that, and I come up with a duration and resources, okay? And once I have, then inside the company, we know, for example, for what is our cost for a mechanical engineer? What is the cost for a manufacturing engineer? What is the cost for a technician? What's the cost for a quality engineer? What's the cost for an assembler? What's the cost for a manager? Okay, so and so on and so forth. So we know all of these charges, and I know how many hours I want to estimate, and then we take it through a review cycle. Okay, it goes through several review cycles, and they come back with, they say, oh, you are under, I think you're being not conservative enough, maybe you got to do this. Or sometimes they come back, hey, I think you're about $2 million off. Not only you got to bring it down 2 million, go down another 2 million so we can become competitive. Okay? So after engineering gets a chance to look at it, the marketing looks at it, legal department looks at it, management looks at it, operations looks at it, okay? Finance looks at it, everybody reviews it, and then they say, okay, $25 million is good, 50 million is good, and so on and so forth. Then once the project is approved, okay, and I get the money, okay, now I know what my deliverables are, okay. what my key milestones are. Now I know that for the next year, what are the activities and how much budget I have allocated for the activities. Okay, so when you use earned value management system, okay, so you know what your starting point is. You said it's going to take me 300 hours to do this task. Okay, earned value management tells you, are you really 300 hours? Are you more or are you less? Okay, so if your initial estimate is correct and you're close to 300 hours, if you're off 50 hours, even if you're off 100 hours, it's okay. But if you're off 400 hours, okay, so people want to know why. Is it because your initial estimate was off? You were wrong? You did not anticipate certain things? Or is it because you anticipated everything, okay, but we had other issues that we did not anticipate? Supplier, for example, okay, supplier shuts down, closes business, leaves. Oops, I'm stuck in the middle of a design. Now I have to go find a new supply that has an impact, right? That's going to be 6 months, 9 months schedule delay, and it's going to be that 9 months translates into money you have to spend, and then you have to bring them up again. So it's going to be a hit. So earned value management system is the tool that we usually use in the aerospace business. Okay.
Okay. More. So more. I know that you have managed teams, so many teams so far. So can you tell us about the team you manage? What were their roles and how many staff members are there? Like
sure. For example, when I was at Honeywell Defense and Space, and I was working on the manned space flight, I had 2 microbiologists, I had a chemist, I had 3 electrical engineers, I had about 2 mechanical engineers, I had a pump designer, I had a valve designer, okay, I had a manufacturing engineer, I had a quality engineer, I had test engineers, I had 2 R&D lab technicians, I had a dedicated clean room, okay, with all the associated facilities and everything else. And then, so that you're looking at about somewhere between 10 to 12 people, okay? And those are the skill sets. So then we had shared resources inside the company. And the shared resources were, for example, I needed to do a stress analysis, okay? So the stress team was a shared team with everybody, okay? So I had dedicated electrical engineers for the products that used to go into my system. And then I had shared resources with the electromechanical power systems, okay, that whenever I needed minor redesigns or designs, or I needed them for review, or I needed them for delving into really complicated problems, okay, I would use them. Then we had a shared resource, which was EMC, EMI experts, okay. We had about 5 of them. And that was just on one location. We also had other EMC, EMI experts corporate-wide. And then if these guys were busy and they didn't have the bandwidth, okay, and they couldn't help, I would go to Arizona, or I would go to New Jersey, or I would go up north and I say, hey, I need this guy, can I have him? And they would say, yeah, you can have him. You can have him only for 2 weeks, 3 weeks, and that's it. So there were a lot of shared resources that we ended up using. But actively at any given time on my team, I had somewhere between 10 and 12 people. And I have the same thing right now. Right here in LA, I have 8 engineers. In Pittsburgh, I have 4. And in Japan, I have 2. So the number in Japan at any given time can change up and down.
Okay, we are almost in the end of our conversation. So
sure.
I'd like to know what is your compensation expectation?
Well, according to, okay, I'm not going to give you any numbers. So this position is for Northern California, correct?
Yes.
Okay. Yeah. So I will tell you this. Northern California is a lot more expensive than Southern California. Let's say if you pay $3,000 for an apartment in Los Angeles, in Mountain View, you're looking at $7,000. Okay? So cost of living is exorbitantly high. So therefore, when we get to that point, we will cross that bridge. But you need to know that when you move from Southern California to Northern California, there's a substantial amount associated with the cost of living. Okay? And then that has to be taken into consideration. Plus, if I'm moving, then you use your skillful market valuation and figure that one out. But we'll talk about money when the right time comes. But the short answer is, what is the maximum allowable compensation that the company has allocated for this position? What is it that they have allocated?
Actually, I'm not in a position to disclose this right away. So you will get the chance to discuss with them regarding this. But it would be really helpful for us if you just.
I'm not going to give you any money. I just gave you a good indication that the difference in price ranges between Southern California and Northern California is substantial. Okay, let's go through the interview. Let's say we can even set up an interview. We set up an interview. We go through the interview. If there's an interest, at that point we can sit down and dish out and hammer out the details for money and compensation. I think that would be the least of our problem. But let's get there first. We're not even there.
Okay.
This is a biomedical pharmaceutical company, so we'll see.
Okay. As in peak traffic hours, how much time will it take you to commute to Mountain View, California?
Oh, no. I have to move. There is no. You're looking at about 8-hour commute. Okay. So, unless they want, what they could do, another option is for short time. I could fly there on Monday mornings, which would be a 1 hour, 15-minute flight, 1.5 hour flight max. I stay there 4 or 5 days a week, and I come back Friday evening, and I stay here at home on the weekends. But that's only for a short period of time. We can only do that for 2 or 3 months. Eventually, I have to move up north. Okay? So, I have to find a place up there, depending upon the location of the company. I prefer to be on the suburbs, away out of the crowded area, okay? And then a 15-20 minute drive is perfectly fine, not a problem. But those things we'll have to figure out. But initially, I may have to fly out of there for 4 or 5 days and then figure it out.
Well, thank you so much for attending this discussion. It was a really
my pleasure.
Nice conversation, and I was really.
Thank you, sir.
So,
my pleasure. Thank you.
Thank you so much. So basically, the video is being recorded, and these videos will be shared with the concerned company, and they will review and they will contact with you later. So
thank you.
So
I'll be looking forward to it. And by the way, it's a pleasure talking to you. Thank you. Very kind of you.
Thank you so much. See you.
See you, my friend. Have a nice one, will you? Thank you.